What's up, YouTube? So you want to be a code reviewer? Well, then you're going to have to learn to write good, clean code yourself and make that a habit, kind of just happen naturally. And then maybe you can look at becoming a good code reviewer too. Of course, besides a code review, there are typically design reviews, and there are lots of gotchas, which also imply that if you've done these kind of things before, you will see that. You will see the problems, right? You understand the technologies, you understand the NuGet packages or other frameworks that you're using, and each one of these things has certain gotchas, certain do's and don'ts, certain best practices. So it obviously implies many, many factors that go into a good code review or a good code review / design review. In today's video, I want to focus mainly on method design and by extension, class design. But I'm also going to give you sort of my reasoning as I go through the course. I've not reviewed the code. I'll be doing that now. Just a quick thing. And then I want to focus on a very specific idea with regards to method design. And then take you through the reasoning for, so we'll refactor, if you will. And then sort of I'll speak aloud so you understand my thought process and my reasoning for doing certain things. I'll be doing that through this video. So you'll be looking at a lot of code. I'll show you initially what this code is doing, just so you have a basic understanding, but I'm hoping you don't need to have that deep understanding to be able to do the code review. And since I'm explaining my reasoning behind it, hopefully that'll make sense. All right. So let's look at the application. This is a Puppeteer application I've built. It's doing a bunch of things besides automating a certain application, browser-based application. As it's going through the different steps, if you will, execution steps, it's publishing each of those steps and the outcome of those steps to a message broker. In this case, it's RabbitMQ, but it could be any message broker. And then what you'll see on the screen is the sort of subscriber to this message broker seeing the messages arrive at one of the subscribers' end of things. All right, so there'll be two console applications. One will pretty much just stick around till the automation is done. And the other browser application will be showing you the messages being received by the Rabbit subscriber, right? Let's take a look. So I'm going to run this application. There are about 30 odd steps. So this is that's what's going to happen. And, each time the page browser has to load the screen, it might wait for a few seconds, sometimes, 15 seconds to load the page. And then it'll continue on. So as you can see here, step ID is 8. I don't know if you can read that. Maybe I can zoom in. I don't know. Yeah. Actually, I need to do a live zoom in. Right. So you'll see the 32 is loading up a page and then it's done. So that took 36 seconds and this application is done. All right. So let me just zoom in back out here so you can see there's a whole bunch of things that have occurred. So that's the basic application. It's got some sort of an execution sequence of steps, and it's logging a bunch of things or sending that data across to a message broker, and we're seeing it over here. All right, so let's look at the code review. I'm going to start simple with the DTOs and enums and things of that nature, and then move to more the base classes and then descendants. But I'll explain my thought process or reasoning for why I think certain things are incorrect or need to be fixed, right? Okay, so starting with DTOs. All right, so let's do that. I don't know if this is big enough. All right, so sealed, immutable class looks good. Argument names match the property names, that's good. Machine ID, monitor ID, station ID. Okay, that looks good so far. The next is monitor message. Again, internal sealed is good. Immutable get only met properties, but they're using the new feature in C# for immutable properties. Two constructors, that's good. One of the things I do actually care for, it's not a requirement, I do it for my own code. I don't necessarily expect people whose code I review to do the same, but there's a suggestion. The properties are organized in their order of their constructor arguments, right? Now that may not be a good thing in some cases from a performance standpoint. Now I'm going like so low in the performance standpoint with regards to nanoseconds, it may not even matter, but there is an impact to the way you arrange your properties, because that's how the memory manager in .NET will arrange or allocate memory. And if you don't group your properties in the right order, right sequence, things could go a little weird. But that's like so detailed and so nuanced in terms of nanoseconds that you shouldn't really worry about that. But I like what they've done here is it looks like to me the constructor parameters and the order of these properties is in that sense. So they probably decided first on what these properties mean to them. And then based on that, they've done this ordering. And this constructor calls this constructor. So there's this other constructor. Well, looks good. Property names match the parameter names. That looks good. All right. The next is page context. Internal. Why is this class not sealed? All DTO classes should start their lives internal sealed. All classes should start their lives internal sealed. DTOs especially. DTOs are like the data transfer objects. They just have properties. They don't have any behavior. It's a difficult idea to implement in terms of if you're not used to that. It seems like it's an overkill, or it seems like it's an unnecessary pain in the ass. And it may be, I'm saying they start their lives. Start your classes as internal sealed. Start your DTOs as also internal sealed. And only unseal. No, not unseal. I mean, make the DTOs are immutable as well. Sorry, I forgot to mention that. They are immutable. And that also might be considered, not considered, but that might also feel like, oh my God, that's a lot of work for no real benefit. The benefits are fairly substantial. Besides the multi-threading aspects, which may or may not apply to you, or you don't know that today, that it may or may not apply to you. It's the ability to reason about your code. If I gave you something and then you gave that to somebody else and that somebody else, then everyone in the call chain can trust that that thing has not been modified since the person that created it or the thing that created it. That's a very big guarantee, and it gives you a sense of calm and guarantee the assurance that nothing has been modified, and therefore you are getting what you're getting. And also the fact that that thing is valid by the mere fact that it exists as an instance. It's a valid instance because the constructor here will ensure that there are these requirement properties. And if you cannot provide all these properties, you cannot create an instance. Now, you don't see any validations here, which is by design, at least in my applications. We trust each other. If I give you a class that says, here's this class that requires these 5 things, you're not trying to beat the system. Like, I'm not in the habit of unnecessarily writing extra code just to protect myself in that sense. I just say everyone in the team trust themselves. You trust each other, so there's no need for us to check up on the other, right? If I define a constructor that takes 10 parameters, I expect that you to give me all 10 parameters that are valid. Right? You're not trying to beat the system. Right? So anyway, so that class should be sealed. Okay, what's next? So we've done the GTOs. Let's look at the enum. Internal, okay, start, step, finish, end. Finish, end. Start, monitor start, monitor end, step start, step finish. Well, now I know in English, the opposite of start may not be finish, and opposite of begin may not be end, but of course in programming we have this notion of begin, end, and start, finish rather than start, end. Does that make sense to you? So personally, whatever that is, the fact that one says finish, one says end, I would change that so they're both the same. Personally, I prefer finish. I would say, make this monitor finish rather than monitor end and step end. The monitor has finished, right? So it started and it finished. Like the start line, the finish line. If you're saying begin, it would be end. So anyway, I would recommend that, right? Make that change. Okay, then we have base classes. So let's look at the monitor base. What is this publisher base? Okay, let's look at this class first. Okay, so it's an abstract class. This should be protected. What is this saying? change the ability of this constructor to protect it, right? That should be protected. Oops. But you don't need it actually. Personally, I'd say just take it out. You don't need it. It's not disposable. It's the base class. So it implements it may implement iDisposable by calling another dispose method, which is here. Okay. So this is the right pattern for iDisposable. So I want, in terms of the way a base class would define its dispose method and claim that it implements the iDisposable pattern. Public methods are not virtual. The methods, some other methods are virtual, I'm guessing. So publish modulo start end. So the order of arguments is also important. Now you may not understand it yourself as you're doing a code review, but as long as there's a consistency, right? Orchestration ID, monitor ID, machine ID, orchestration ID, monitor ID, machine ID, orchestration monitor ID, machine ID. So that's good. I'll have to check, look at that. Did we see that execution context? Oh yeah, we did. I think I had that orchestration ID. Yeah. Orchestration ID, machine, monitor ID, machine ID. Oh, that's strange. So I would recommend that these be changed to execution ID, since they have this class as the properties inbuilt, rather than keeping it separate like this, right? Instead of keeping them all separate, this is execution, what's it called? Context. Monitor start, monitor end, publish monitor start end. Okay, here, so now this method is called publish monitor start end. The publish monitor end and the publish monitor start in turn are calling this publish monitor start end. Because it supports start and end, I would really change the signature such that this enum is the first thing. So in the signature for the start end, basically what I would say is I would move this enum to be the first thing, since that is the first aspect. It's start or end, right? And then would be that orchestration ID. And elapsed milliseconds. Yeah, so I would sort of do that. I would recommend this because these three are actually all combined in this one DTO, like that. Right? So that's what I would recommend. Okay, I won't change it. I won't, but keep that in mind. So method design, that's the focus of this presentation of this episode. But it implies many, many things. Sometimes it's just sequencing, sometimes it's just naming of methods, naming of parameters, return types, and then in the implementation itself. So there's a lot of aspects to method design. And I find method design is the hardest thing. Maybe design is hard. I'm not sure which one is it. But the problem is, the idea is this. If you can design a method correctly, you can design a class correctly. If you can design a class correctly, you can design a system correctly, and so on and so forth. So method design, it all starts from there. Can you name things correctly? Can you, the sequence of the order of arguments, parameters, and then this refactoring. So I can understand you start off with something like this, right? And then at some point down the line, you decide to introduce this class here that has the three properties instead of them being disparate properties here. Then you should go back. Every time you do a little bit of a change, go back and refactor all of that to kind of be in step with your new idea, your new thought process, right? Otherwise, what happens is if you leave it for later, you'll forget it, right? And then it's up to some code reviewer who's not spent that week or 2 weeks on that code, right? They're having to really immerse themselves in this coder's mindset, but in a matter of minutes, which is a really hard thing to do. So as a person writing the code, you should be doing that refactoring kind of as your, by refactoring, I mean, you do it clean up after you start a certain refactor. You added this execution context class, go back and implement that across the board before moving on, right? All right. So anyway, we'll have to change that. I'm going to leave all these errors here. Normally I'd write a note to change all these things there. But I don't know enough since we're just looking at this one base class. So let's look at the other base class here, which is this monitor base. Okay. This is what I do with Visual Studio. I'll select that and it'll highlight everywhere where this thing is being used. So this looks like a constant. Where is it being used? Okay. Oh, there it is. Once. So it's only being used once. Why is it a constant? Is it protected? No. Okay. I can see that this might seem like it should be a constant unless there's a valid reason for it to be made a constant. As in, this is what, what I call it. Don't try and imagine that I might need this. This may happen. That could happen. What if this? Too many imaginations. Just stay focused on what you know now. At this point, I'm thinking, I don't know if that navigation timeout is going to be required beyond that one method. Right? So yes, it means that you have to be on your toes. Every time you make a change, you have to kind of have a holistic think again. Right? You have to think holistically again because you make a change. Does it now require to be a constant? That sort of thing. Sure. But if you make this a constant now and a member constant, it'll be forgotten. Nobody's going to look at it. Right? And you're not showing me your intent. By declaring it as a member constant, you're telling me you intend to use this in multiple places. But if you're not, then you're going to confuse me. By me, I'm the code reviewer, I'm the future you, I'm the person maintaining the system 5-10 years down the line. So you're thinking in those terms when you're writing code. Programming with intent, that's all about. That's what it says. Show me your intent. So I would actually say take that out and declare that locally. Stopwatch. Okay. Where is this being used? Now I know there's some code goes beyond this. I might miss stuff there. But it's nowhere. Oh, there it is. Where's this? Execute step. Start, stop. It's inside of a try. Okay, so it's publishing the time that action, whatever that action is took. Start that timer, do the action, stop the timer, record it by publishing it, and reset it finally. Okay. Does that need to be a member? Okay, now you could declare this locally. There is an issue with timers. By that, I mean that you don't want to create too many of them. So I don't know exactly if the stopwatch falls in that category. As can you create new instances of stopwatch each time? Or should you reuse the instance? I'd go with the reuse the instance just because it's clearer. You're really saying I don't intend to create a new instance each time, or there's no need for it. So it's okay for it to be a private member, only to be used in this one method to record the time across the different executions. There's probably there's so many steps that are being executed. How many timers do you want to create? 30, 40, 60, 80. Maybe that's just not, what the headache that might occur if you created so many timers, stopwatches. Right? All right. So I'll leave that for now. Okay. So anyway, that's what I do. I look at I highlight these things to know where it's being used or what's being done. Navigation options. I'm guessing again, it's being used in multiple places, but you get the point. I won't go through the whole process here for every piece of code now. Then we got the execute method here. Oh my gosh, my head is hurting. I'm just going to zoom out a little bit so you can see this whole method in one shot here. All right. So what do you think of that method? To me, it's like, oh my gosh, I cannot read this. It's just too much. This levels of nesting, I cannot handle it. But that's fine if that's what you need, right? What can you do? But you don't. There's some problem here. Let me see if you can tell me what that is. It's not a problem. Maybe some people don't know it to be a problem. So I'm just going to tell you what it is. If you want, you can pause the video and think about it and then start a video and you'll hear me giving you the solution. Nested usings and then there's a try catch. So this code is going to be compiled. At compile time, it's going to translate to a nestings of try finallys, and then inside the innermost try finally is a try catch. That is not code you want to write, because that every try finally is going to cost you something, right? What you could do is roll up all these usings one underneath the other. So what I mean by that is something like this, right? You take that out, and do that. And this might look a little confusing right off the bat, but let me just tell you what is the intention. Okay. All right. So that's what it is. You can declare the three usings like one behind the other or one underneath the other with only one open curly. And this does not translate into a nested try finally. It's a single try finally, but you still have a try catch nested inside of a try finally. And when that happens, I prefer to just have a try catch finally. Right? So now I'll do all the stuff myself. I don't like to use using just because, right? That's just not the right way to do it. The newer syntax you could also use is you could do that, right? You can just say it's done like this instead of with the curlies and all. These are the using statement instead of or expression. You can do that as well, something like that. Might have made a mistake here. No, sorry, you don't need the parentheses, right? It's an expression. Okay. So you can do that in the new syntax, and that should be fine too. Right? I don't know what it's complaining about. Maybe it's not the right version. Yeah, so this is not the right version. Okay, so undo it. Should have checked the version. Okay, so this still translates to a nested, a try finally, and then a try catch nested inside a try finally. So in those situations, I'd rather just do this as a try catch finally, right? And so we just do that. I'm going to quickly make that change. I'm not really, I've already done that. Let me do that here. So here's the change. It's I've got these. So look how cute that is, right? It's kind of like a dwindling. But maybe cute, but is it right? I have my own nuances, my own little quirks in how I write code. Some of them have a damn good reason for it. Most of them do. And some of them are just, to be more intentful. Some people think they're such a small thing, Shiv, why does that really matter? Well, if it's such a small thing, then do it. I don't see why not. I'll give you my reasoning. You may or may not agree with it, but that's what I think. So, but before I can tell you anything about that, it just looks cute. So it may be right. I don't know. All right. So what we have is we got a try catch finally. And in the finally, we got these three things being disposed here. I thought there was, yeah. These are only two things being disposed. I think this was, what is it? Was the publisher that was disposable? Yes. Okay. So obviously it's missing the publisher. All right. So publisher dot dispose. This is this null conditional operator is, I don't like it. This is probably the only time I use it with the, like a finally with the dispose, we have to check to see if something is null before you dispose. So it's so convenient for that sense. I see chains of these, and then people, when I ask the dev, what do you think is really happening? They haven't a clue. They can't explain it. They're being safe all the way, right? So-and-so dot, so-and-so dot, so-and-so dot, so-and-so, and each of those dots is a question mark dot, question mark dot, question mark dot, so just blindly. Please don't write code like that. That is, think of it. The convenience is okay. Okay, the convenience doesn't make the code simpler. The convenience is not making the code any different at compile time. But the human mind still has to be able to understand it, right? The question mark dot, question mark dot, question mark dot, a chain of those implies if this is not equal to null, then if this is not equal to null, then if this is not equal to null, then if this is not equal to null, then. Is the human mind able to understand that? Right? My mind is not. Okay, I'm not that smart to be able to wrap my head around it. I don't like complex code or complicated code. So I'd rather just see it simple. But for the most part, I find the developer is just taking the easy way out, right? They just think they're being safe. And that's what I have a problem with mainly. Don't be safe. Like, coding is not about being safe. Coding is about being sure. It's either going to or it's not going to. There's no in between, right? 9 times out of 10, you can be confident if you did a little analysis, a little thinking, if that thing can ever be null, right? In the way I write code, and of course, this is like a small portion of what you're seeing here. I don't have nulls in my application. Right? The data never comes in as null. It's always cleaned up, and if it's not agreeable, it's thrown out. So I'm never dealing with like unknown things in my application, in the main code of the application. So there's no question of wondering if something is going to be a null or not. So if you did programming like that, then I don't know if you watched that video. I'll put all the links to my videos over here you'll probably see it later after the video. The programming with intent, the first one on method design, I have this idea of if you lock the front door and you lock the back door, you're safe in the house. If you lock the front door and you lock the back door, you're safe in the house. Basically, if you lock the data coming in, it's cleaned up before it's allowed in from like say UI and things of that nature, service calls. And conversely, if you make service calls out or in your database and you let that data come in from the back door, if you clean that up and make sure that's good before it comes in, then nowhere in your system do you have to be worried about bad data. Right? So then you lock the front door, you lock the back door, you're safe in the house. But here it's fine. I think this is because you don't know, right? With the way it's declared, let's say it could create this publisher. This is the factory method, by the way. You can see the make prefix that indicates the factory method pattern. So there's a publisher, and let's say this blows out, or maybe this blows out. It's not yet created the browser and the page, and so you have to check before you can dispose of the page and the browser. Now this may not be a good idea, right? Because you're doing the test twice. So this is simple, easy code, but you see that you're checking it twice. It looks like, oh, it's just 2 lines of code. No, it's quite a bit more. So here I would actually do something like this. If, browser is not null, then you can do both those things, right? You can do the browser dot close async. So it's not, coding is not about convenient code. It's about writing the right code. Dot dispose. I don't know if close and dispose do the same thing. Typically in what's it saying? Oh, wait. So we can take those things out. Okay, I'll still like to go back to this code here. But so with regards to try finallys, if you're doing this by hand yourself, right, instead of using, the way you want to look at the classes is the one that you create the last inside of your try part is the first one to dispose of in the finally, right? So the last one to be created is the first one to be disposed. The second last one to be created is the second one to be disposed. You see that, like, they're concentric. They don't overlap. They're not like that. Right? They're like that. I'll show you a diagram here. Made specifically for that. It's kind of like this. So think of these as variables being declared in this order. So created, I don't mean declared, created. So if this page is the last one to be created, then it should be the first one and the finally to be disposed. And browser is the second last one, was created before the page, and therefore it should be the next one to be disposed. And the publisher, which is created before the browser, should then be the last one to dispose. So that is the sequence of things you need to be disposing if you're doing your own try finally and creating your own instances inside of the try. So going back here, let's look at this now. The page is the last one to be created, so it's the first one to go. The browser comes before that, so browser is the last one to go, next one to go. And the publisher is the first one to be disposed. Created, sorry. So it's the last one to be disposed. Right. So this sequence is correct. Right. Now let's look at the order of declaration here. So with regards to ordering, this looks all cute and all, but I like to declare the Ideally, of course, you would declare it just before you need it, but because these are being disposed of, why is this outside here? Okay, because it's being used in the catch. All right, so I would declare them in the other way, which is the order in which they are being constructed. Right, so publisher first, then browser, then page, and then execution context, right? So execution context should move to the bottom. Publisher, then browser, then page, and then, oh, that was it. So to swap that first one to last one out. So publisher first, browser second, since it's being constructed second, page third. I know it doesn't matter, right? But the thing is, when you write code, don't you want to be meticulous about what it is? Even if you don't agree with this, if you have your own thing, what I'm saying is whatever it is, it should be consistent in your entire in the application, right? The idea is not that you have to follow my thing. I'm very particular about these things, but I'll follow this across my application, across all my systems. It's consistent. Consistency is more important, right? Whatever that pattern is, it needs to be consistent. Don't write code, just slap, stuff together and say, oh, it's working. On my team, if it's working, I'm not impressed at all. Now, because I'm speaking in hyperbole, so please understand. Getting it working is not the struggle, right? If that is your struggle, you're in the wrong career. Certainly, if you're a junior programmer, I understand that, that's fine. I'm talking about like a mid-senior engineer. Getting something to work should not be your struggle. Hopefully, what you should be struggling, or where you should be spending most of your time, is the design, is the thought. What is the right way? Of the 5 different ways I can make this work, which one's the right one? Why is this better than that? All of the debate that goes on in your head, all the debate that you might have with your colleagues, teammates, that's the important part. Arriving at the reasoning for you decide to go down this path. Every decision has a reason and a purpose. It's not just because you sort of fell upon it, or because it's working, you left it alone. I'm hoping you're not writing code like that. Every line of code you write has got a reasoning, a meaning, and a purpose. It's well thought out. There's programming with intent. You know exactly why you're doing something. It's the reasoned line of code. It's not just something you just blurted out and because it's working, you left it alone, right? I can understand that when you're getting something to work, that's kind of how you write the code. Then you go back and you clean up, you refactor, and you go back and you refactor, and you go back and you refactor. And finally, you send a code review to me. If I'm going through that process, oh my gosh, it's not going to be a pretty sight. I don't want to be writing, reviewing code at that level, but every line I'm saying, like, what have we done here? Like, why is it like this? Why is it like that? Right? It should be hopefully some code that's been well thought out and written, with some thought process, some intent. Show me your intent. If I can't understand your intent, I'll ask you a question. But if you have no intent at all in your code, there'll be way too many questions. Okay. So without trying to understand this whole thing, I want to see this make publisher method. Okay, public abstract, yes. So this is using the factory method here. Make publisher, the abstract method here. Execute core. Okay. Make browser. Yep, another this is the factory method pattern, not the factory, but the factory method pattern, because it's starting with the prefix of make, and they're both virtual or abstract. Does this, what is this using? Okay, every method should start its life as private, but within a class, every method should also try and start its life as private sealed. Sorry, private static. I know we're in an object-oriented world, but I'm talking about helper methods. If a method, this protected method or some other method, is using another method just to get some little things done, that's like that helper method. Certainly needs a good name. It can't be called helper. But it should be private static, as in it should not rely on state. It should be autonomous, or pure. I talk about these kind of concepts again in that same video on programming with intent, the part 1, but I explain autonomous methods and pure methods. Methods should strive to be autonomous, self-standing, self-sufficient. You give them everything they need, and they operate on only the things that you give them. They don't operate on state, right? What is this method doing exactly? It's not doing anything else besides operating on what it's got. So this method should actually be static. Now something breaks, I don't know, it's not valid. Yes, so it should be static. So when you define a method like this, just make it a habit to say private static. You don't know yet, private static. You can always change it. But when it's not working. But if it's working, if it's public, let's say if you didn't make it private and static, if this was public and it's working, you're not going to go back to kind of make it less visible, right? So get in the habit of classes starting their lives as internal sealed, details start their lives as immutable, internal sealed, immutable, methods start their lives as private static. Unless you know that there's like you're using polymorphism, faculty method pattern or some sort of an override you need to give your descendant classes. So I understand that, but other methods, private static, right? Okay, so no, there's no errors here. That's the method we're looking at. So I'm going to skip on here. Oh, what's this here? Okay, that seems bad, right? It just doesn't feel right. Why would you use the same thing over and over? Now, it's a property. So in .NET, properties are, if you define something a property, how do you decide whether it should be a method or a property? Right? The guidance is this. Properties don't do work. They're simply returning a value. They're not going out and getting that data or getting that information every time you call them. That's method. I'm hoping this machine name property is not going out and trying to discover the machine's name using a Windows API, right? It's already got it. Once it's got it, it kind of retains that. So I'm hoping it's as efficient as like a local variable. But nonetheless, this is not feeling right for some reason to have to call some other, .NET method each time, multiple times. I don't know where else this is being used, but this method is already being used once. Wasn't this? Thought this is called machine ID. Yeah. Okay. So, there's this thing, you'll hear me say this quite a bit times here. Don't invent names. Don't invent names. Right? If your machine ID is nothing but the machine name, why are you inventing a name? Leave it as machine name. Now, unless there's some business need for it, which I cannot imagine, so I would recommend that. And you're going to have to justify why you want it to be called machine ID instead of machine name. Right? If you can't justify it, then you're going to have to change it to name. So my recommendation would be this should be where did it go? This execution context. Yeah, this property should be called machine name. I don't know what ID means, but machine name, and since it's a string, I'm guessing that's good, and so this should be a machine name then. So it's different from IDs, which are potentially GUIDs, right? So I would recommend that. You would have to justify if you can't. I mean, maybe there's a reasoning for it I don't know about. Hopefully you reasoned about it, right? You just not just slapped it together. So when I ask you why you call it machine ID, you have a damn good reason for calling it machine ID. And I'm going to give you my reasoning for why it should be machine name. All right. Okay. So that would be another recommendation. Now, I don't know if this is obvious to you now that this has been cleaned up a little bit, but I'm able to sort of see the forest for the trees. Here's the method, is public, right? And it does this orchestration. I don't know if you can see that. There's orchestration here. Make the publisher, make the browser, get the page, execute. This execute method I thought was a abstract method here somewhere. Right. So this is a base class, and descendants can override this method, but descendants can also override the make publisher and the descendants can also override the make browser method. Right? So does this look like a pattern to you? Think about it. Pause this video. Think about it. It's been discussed on my channel before. And then come back and I'll tell you what it is. It's the template method pattern. The template method pattern allows the base class, the ancestor class, to control the orchestration, the sequence of steps. But the ancestor may allow descendants, by way of virtual methods or abstract methods, the ability to modify the implementation. They can't control the sequence, but they can control or change the implementation. This is the template method pattern. So in addition to the factory method pattern here, it's also using the template method pattern where it's calling the sequence. First make the publisher, then make the browser, then get the page, and then it's doing all of this stuff, right? So the designers don't have an opportunity to control any of this. This is completely implemented in the base class, right? This one method execute. But designers are getting the opportunity to make some changes to the make publisher, to the make browser, to the, what was the third one? Make publisher, make browser, and page. Yeah, how to get the page. So then the execute code is left to the implementation of the descendants. So essentially the descendants are not able to control this orchestration. All of this is going to happen first. Then the descendants can do their thing. And once they've done their thing, then this happens. And of course it handles all of all the issues, and also disposing of all the things that are created. There's a problem in this code here. Anyone see it? Okay. If you don't know, pause and, you think I get more time. If you want, I can scroll this down a little bit, but it's irrelevant. It doesn't really matter on that end. Well, there's another problem. The more you show me, the worse it's going to get. All right. So pause if you have to, and, think about it. So this page could be null, right? Because there could be an exception that occurs, let's say over here, it hasn't yet got to the page. Since the page is the last thing being created, the publisher is the first thing being created. So the publisher fails, it won't even, but it'll come in the catch, so that you might want to check for that as well. So if publisher is not null, it could blow out here, right? And it goes to publish a message, but the publisher itself is not null. So both of these have to have a null check before they can be used. Right. This is unfortunate because of the way the code is. By unfortunate, I mean I don't like to have conditional checks all the time. So you could have, in this case, I would say, yeah, use the null conditional operator, right? Because it retains the cleanliness. So you understand what I'm saying with these C# features, right? That if a feature has a potential to cause pain, I don't like them. But I give them kind of very, very restricted use. Only use them in these cases, right? Never change them, that sort of thing. Just so that people don't get in the habit of thinking convenient code is good code, right? Convenience is not good. It may be, may not be. But in this case, like for the dispose, I'll use that over there. And for the page, I'll use that here, right? So this might be acceptable here. The other problem I saw was this. I saw this screenshot options. Where was it? Somewhere down here. Right. Okay, it's a slightly different value. Full page false versus full page true. But here's my reasoning, or here's my thought process. I'm guessing this method is getting called that 40 odd times that we saw it getting called, right? And that's a lot of objects that all have the same property. Instances of this object that all have the same property is not being changed, right? So what I would say is take this thing, declare this as a member of the class, and use it here. So it's the same object being sent over and over again. There's no need to unnecessarily create garbage. Does it make sense? Okay. So I would just say take that out, declare that as a local variable. Not local, I meant member variable, and then use it over here. There's absolutely no reason to keep creating that same instance over and over and over again with the same values. Okay. Yep. This is not being used here. What is this saying? Remove this useless assignment. Remove the useless assignment. Probably say you're not using this member somewhere, anywhere here. It's probably, I know what happened. It's supposed to use, yeah, there it is. It's to be, they've written a to do here, but so they left it there. Okay. Okay. So now I think we've done this basic code review. Now I want to look at the refactoring.